Um, yeah, we have this workshop today, but there's 2 more workshops that everyone is able to attend for UPE Make. It's gonna be 3D modeling with Fusion 360 and computer vision for robotics. Last semester, we did one robotics project, and I think it's gonna be really cool if UPE Make creates a couple more projects regarding robotics. That's why we're doing computer vision with Raspberry Pi as one of our external workshops, right? However, if you become a part of our program, you're gonna have access to the Intro to Arduino Part 2. Today we're gonna start like very basic with the essentials of Arduino and all that. But the next workshop that is gonna be internal, we're gonna do more cool stuff. We're gonna be, for example, talking between 2 Arduinos using serial communication. We're gonna grab one chip and we're gonna read at the schematic and how to implement it with Arduino. For example, something that you use a lot when doing robotics, you need to have a motor driver, right? So in that workshop, we're gonna grab that motor driver chip and how to implement it and everything. We're also gonna go deeper with libraries. And yeah, again, if you wanna get started with Arduino, definitely consider subscribing to our program. It's really cool. 3D modeling with Fusion 360 Part 2. I don't think one workshop is enough to really give everything that you can do with Fusion 360. And if you've ever been interested in 3D printing, 3D modeling, definitely come by. I know 2 of our committee members actually got started with Fusion 360 because of our workshop. So you never know. You can come to a workshop and maybe you grab a new passion, right? And finally, the Robotic Arm Kinematics. This is another continuation for our robotics kind of projects that we're doing this semester. We're not gonna have any hardware, but we're gonna go through all the ideas that go behind, like not only building a robotic arm, but how do you move it to where you want it to go and stuff like that. It's really cool because maybe next semester, if we're able to attend to physical meetings, maybe we can join some of these workshops together, like the computer vision with the robotics arm, and maybe we can create a cool project where those 2 things work together, right? So if you're, yeah, Raul already sent the link. I was gonna mention that if you wanna be able to participate in these workshops, or if you wanna be part of a community that focuses on hardware related stuff this semester, don't be shy. Just apply. The deadline is tonight, so if you want to, just don't forget, because tomorrow it's not gonna be able, and you're gonna have to wait till next semester to become a part of our program. So yeah. Consider it if any of those workshops interested you, because these 3 are going to be only for the members of our program. And we also have a Discord. Most of you guys already know it, but if you are not in the Discord, this is the link. Dulia, honestly, if you're not sure, you could probably just apply again if you're not sure. But I'm sure Raul can have an answer for that one. Also our social media, all of our events. Yeah. All of our events happen and they're all marketed through social media too. So you don't want to miss anything out. Definitely follow us there. And yeah, this is our Arduino workshop. It's similar to the one we had last semester, but we're switching it up a little bit. So what is an Arduino? And that's a good question, right? An Arduino, it's usually referred to as a microcontroller, but in reality, it's a PCB that contains a microcontroller, as well as a bunch of other features that are great for quick prototyping and stuff like robotics and so on. the microcontroller side of the Arduino allows you to take inputs from external modules or devices, for example, buttons, maybe a Bluetooth module or like a light sensor or something. And then you can program the microcontroller to be able to create the behavior that you want through the output pins. So maybe you have a distance sensor, right, for your robot, and the inputs are telling that you're getting close to the wall. Well, you program it in such a way that once you get to a certain state, you move the robot to other place or go backwards or stuff like that. So it's just playing with the input pins and saying what behavior you want to do with the Arduino, so you can set it in the output pins. But you may ask yourself, why an Arduino? I mean, there are tons of other microcontrollers boards that are actually more powerful than an Arduino and probably cheaper too. Well, the answer for that is the whole idea with Arduino is that it's a great way to get started into any type of embedded development, since they basically created it so it's as simple as possible to just get started with manipulating pins. There's tons of libraries and stuff like that. So the programming environment is actually pretty simple compared to the regular like difficulty that comes with programming any other kind of microcontroller, where you have to read the whole data sheet to see like the registers and all that. The Arduino just skips that and gives you a very easy way to do it. It's also very inexpensive for any of your projects. A Raspberry Pi is $50 right now, but you can get an Arduino from eBay for like $8. So if you have any projects or anything, or even cheaper if you get them from China, like Arduino Nanos from China is like $1 a piece. So yeah, that's definitely one of the things. Large community, any problem that you're gonna have while developing Arduino, probably someone else already had it and they posted about it and there was a solution about it, right? Whenever you're trying to learn something new, always try to go with something that has a large community, because that's going to be the safe net whenever you run into any problems. Libraries available. Yeah, all the modules. You can have LCD screens, you can have Bluetooth modules, you can have IR sensors like we're going to do today. There's libraries for all that, because if not, you will need to spend all this time just developing your own library for everything. And that's not how you do quick prototypes, right? And that's what we want. Open source, you have access to everything about the Arduino, all the code, all the schematics, everything. And this has basically allowed the community to create, since we have the schematics, they create their own versions of Arduino, right? There's Arduinos that are created just to run 3D printers. There's Arduinos that are created for all kinds of purpose. There's also these things called Arduino Shields, which you put it on top of the Arduino and it enables extra functionality in it. There's shields that have LCD screens. There's shields that are made only for robotics projects that have like motor drivers and everything in them. And you can save a lot of time with that. It's also a multi-platform, which means no matter which computer you have, you're gonna be able to program for it. And it's USB programmable, and that is huge. Usually microcontrollers, you need to have, usually for microcontrollers, you need to have your own programming cable, and it's really complicated. And with the Arduino, you just need a USB plug, and that's it. So I think that's about all the reasons why you would use an Arduino, at least in my opinion. When you look at the GPIO, it can look quite scary in the beginning. You're like, what's happening? But in reality, it just boils down to a couple things. You have the digital pins, the analog ones. I don't think you guys can see my cursor, so let me go back.
We can see it, don't worry.
This is better. You have digital pins analog pins, power pins. So what do you do with digital pins? If you ever seen how a computer works, they works with zeros and ones, and everyone knows that. But in reality, what that means is a state of low or high. In the Arduino, since it works at 5 volts, a digital pin can either be at 0 volts or 5 volts, right? So that's what you would be doing with these digital pins. Something that you'd notice is they are called I/O pins. Really, well, technically GPIO pins, and that stands for general purpose input or output, right? So any of the digital pins, you can use them to output a signal, maybe to turn on an LED or something, but you can also use them to input a signal. Maybe you have a button, and when you press it, you want to detect that, right? So that's something that you have to have in mind, because depending on the usage of your pins, you're going to have to program that in the beginning of the code. You're going to have to tell the program, do I want to use the pin as an input or as an output? And we're going to look into that here in the program. Here in the following sketches that we create. But yeah, something to have in mind. The analog, however, the Arduino is a digital device, right? By definition, it cannot really create analog signals. It can try to create them, but not really. So the analog pins actually only read analog signals. They don't, it's only input, not really output. However, and this is like a fun fact or whatever, if you run out of digital pins, you can actually use the analog pins, all of them, as also as digital pins. Not a lot of people know that. And once you start getting into bigger projects and you need to use every single pin that you have, that's really useful. Another thing, let me think. Oh yeah, the power pins. Yeah, you're gonna end up using modules, Bluetooth modules, or our IR sensor needs 5 volts, Bluetooth modules need 5 volts. Basically anything that you connect to the Arduino, you need to put power in it. And more importantly, you probably need to connect the ground together. So for any kind of power requirements that you need, you're gonna use the power pins. And finally, you probably see here in gray these things right here. We're not gonna talk about them a lot in this workshop. It's gonna be mostly in the next one. This is communication protocols that the Arduino has. You can, for example, communicate with external modules like screens. I don't know, there's tilt sensors and stuff like that. And usually they communicate with communication protocols like this one, I2C, SPI, or even UART. In the next workshop, we're gonna actually use UART, which is serial, to communicate between two Arduinos. So that's gonna be really cool. You're gonna be able to send a message from one and then receive it in the other one. Why would you wanna do that though? Well, there's gonna come moments where you run out of pins, and in that case, a good solution is just to add another Arduino into the system, but you still need to communicate between them, right? So that's how you would do it. By the way, if any of you guys have any questions, just let me know. I'll be more than happy to explain them. But yeah, what are we gonna learn today? Well, I already gave you guys like a little insight of what we're gonna learn, but the projects that we're gonna do is basically we're gonna start just making a simple LED blink. Then we're gonna make that LED fade in and fade out. Then we're gonna use a potentiometer. After that, we're gonna use a servo motor and control the servo motor with the potentiometer. Finally, we're gonna use an IR sensor, which is an infrared, an IR receiver. So if any of you guys have used any TV remotes or anything, the way they work is they send an infrared signal, and then you can receive that and decode it and create functionality with that. So we're gonna have basically an IR remote and our Arduino receiving the signal, and then with that signal, we're gonna turn on or off certain LEDs. So yeah, and then if we have time, which I don't know if we're gonna have to, depends. I have an extra project that, well, if we have time, we can definitely look into it. So okay, sorry. Let's get started, right? A simple blinking LED. So what's the functionality that we want here? Where we're gonna have one LED, as you guys can see here. It's connected the negative side, the anode, to ground, and the positive to pin number 13. You see that it has a resistor. Why is that? Well, LEDs usually take more current that they can really support, right? So if you connect an LED with a resistor in the middle, you're gonna end up burning the LED. So that's why we added a resistor there. And basically, the terms that we're gonna introduce to make this possible is how to use digital signals in Arduino. By using digital signals, we're gonna be able to turn on or off the pin that turns the LED. Also, we're gonna see like the basics of how Arduino programming works: setup, loop, digital write, and delay. So yeah, I say we get started, right? The first thing that you would do is just go here and go for Tinkercad. So, okay. As you can see, Tinkercad is also used for 3D modeling, and I have a couple projects in it. But once you're here, you should be able to click on sign in and use your Google account. Your FIU email works. That's what I do. It's the easiest way. So you sign in there and you're in. So you have 3D designs, circuits, code blocks. We're gonna go to the circuit section. And in here, you're gonna create a new circuit. Yeah, I'm gonna wait a couple minutes so you guys can let me know if you were able to get here. But yeah, it should be easy. You just use your Gmail, go to the circuit section and create a new circuit. Once you're able to do that and you're here, you're gonna notice, I know, right, Kim? It's, especially when doing circuits, it's really difficult to understand what's happening if it's an actual breadboard with a bunch of cables jumping around. To have it like visually and all the cables be color coded is like amazing for learning. I don't expect many of you guys to have used a breadboard before, but I hope this workshop can be a great introduction for that. It's definitely useful for any Arduino project that you create. I know, Nicholas, did you do Tinkercad workshops for Ignite? Maybe? I don't know. For work. Oh, okay. Oh yeah, I remember Raul telling me about that. He is a Tinkercad Pro after all. So okay. Once you're here, you have basically your playground. You also have on the right basically like your element search, and here's where gonna have all the elements that you can use. And finally, up here you have a tab where you can code and then start simulation. You only start the simulation once your project is done. But I just say like, go ahead and just search for an Arduino here, right? You find the Arduino and you grab it in here. That's pretty simple right now. After you find the Arduino, you're gonna go look for an LED and you're gonna put it up here. So I actually said it wrong. An LED is polarized. So that means that you cannot just plug the pins anywhere. It has an anode and a cathode. The anode has to go to the positive side of the circuit. In our case, it would be 13. And the cathode goes to ground, right? But I did tell you guys that usually when you're working with LEDs, usually not always, you need to put a resistor. So we're gonna find a resistor and we're gonna put it in here. And then you connect both ends of the resistor, one with the LED and the other with the Arduino in pin 13. So I'm actually gonna change the color of the cable. Okay. Usually with real LEDs, the longer side is gonna be the positive, which is the anode. But here in Tinkercad, it tells you literally if you hover over it. That also applies because there's capacitors that are polarized too, and they have one leg that is longer. It's like common with electronics. I'm gonna change the color of the cable so it's easier to understand, but you don't have to. Yeah. Well, if everyone is that too, that is true, Jose. That is true. Hi, Denai. So yeah, I'm sorry, I'm spacing out. I'm sure everyone has this correctly. So we just go here and select code, and then where it says blocks, we're gonna go for text and then continue. So here we're gonna introduce the concepts that I told you guys. So we have, actually they already give you the code that we need to run this, but we're gonna delete it because yeah, we wanna do it ourselves, right? So you have two functions in here, setup and loop. If you've ever used Unity, it has something similar. Setup runs only once at the beginning of the program, and loop runs infinitely many times after setup. So what things do we need to put in setup? Well, we need to tell the program if we're gonna use our pin as an input or as an output. So the way that you do that is pin mode. You select the pin number, which in our case is 13, and then output. Why is it output? Because we're outputting the 5 volts that's gonna turn on the LED, right? Also, yeah, if you guys have any questions, let me know. I'm just moving the chat here a little bit. Okay, so we already told our program what we're gonna use our pin for. We're good with that. So we go straight away to the loop. So what do I want to happen here? Well, I want to turn the LED on first. So the way that you manipulate the digital pins is by using digital write. You put the pin number and then the state that you want the pin to be in, which is high. High means 1. High means, on. Low would mean the opposite. So since I just wanted to blink, I want it to be high and then digital write pin number 13 to be low. Now, if we run the code, it should work, right? Well, we had a problem. Just give me 1 second. Pin mode. Okay, so yeah, that's how you write it. My bad. By the way, can you guys see the code? Because I don't, yeah, it's probably too small. That's probably better. Let me fix this. It's good now. Yeah. You have pin mode. Yeah, I wrote it wrong. It's that way. If you run it now, what's gonna happen is the LED is gonna stay on. Why is that? Well, since this is a loop function, what's happening is the LED is actually turning on and off, but it's happening so fast that you cannot tell that it's turning on and off. So to solve this problem, you have to introduce delays. And Arduino has a delay function already set. It's called delay, and then you put the parameter in it in microseconds. So 1000 would equal to 1 second in real life. So 1000 and 1000. In this simulation, it may take more than 1 second because it's running slowly depending on your computer. But by adding a delay of 1000, now you see it blink. And we have successfully created our first Arduino project. This is the equivalent to Hello World, but for Arduino. I know, right? Yeah, the stripes of the resistor mean the value. So I don't know the value by memory now, but something that you're gonna notice is if you change the value right here, for example, 4.5, the stripes go like start changing colors, right? So every color has a definition. There's a YouTube tutorial out there that is really useful for that. However, sadly, I never really learned how to read the stripes. But if you're interested in that, definitely good to learn. But now, this is the first. Yeah. Well, you can always use this is what I do. If you have a multimeter, you can test the resistance of a resistor. Usually it's good to do it anyways, because you want to make sure the resistor that you're using is working fine. But you can also check the resistance that way, right? If you have a multimeter. Yeah, so we're gonna leave this like that for now. And we're gonna go to the next step, which is gonna be creating well, this is the source code, but you guys already we did it all together. A fading LED, right? So what's the difference between a fading LED and a blinking one? Well, the blinking only goes from the pin in the LED only goes from 0 to 1, 0, 1. That's why it's turning on and off, right? Yeah, there's phrases for that. I know that there's like a chart. If you ever buy like a resistor box, it comes with a little card and you can see all the values in it. The difference with fading is that we need to simulate what an analog signal is. You know, the opposite of a digital signal is one that can actually change values in between from 0 to 5 volts, right? However, our Arduino is not an analog device, it's a digital one. So how do we do this? Well, there's actually a really cool process where you can simulate analog signals, and it's called pulse width modulation, PWM. It's basically a technique that allows you to create analog-like signals, but with digital pins. So the Arduino has a PWM like functionality that goes from 0 to 255. Basically has an 8-bit PWM circuit in it. So it's gonna make more sense once we start working with it. But basically, if you put 0 in the analog function, it's gonna be the same as if it's turned off. And if you go higher and higher in the values, it's gonna be closer and closer to 5 volts. If you have any questions about PWM, let me know. I hope that explanation was good enough. But basically, you create these fake analog signals using the analog write function, right? So yeah, let's do a fading LED sketch with PWM signals. So yeah, now we have this one here, and for this sketch we're gonna keep the same circuit, but we're gonna change the code. So I'm actually gonna get rid of this part, and yeah. So for example, if you use analog right here, our pin is number 13, then you could put a value in here that ranges from 0 to 255, right? However, I want it to be changing from 0 to 255 by itself. So what I'm gonna do here is create a for loop, right? So for this for loop, basically I'm gonna have a variable called brightness, and it starts at 0, then brightness has to be less or equal than 255, and brightness plus equals 5. So what's going to happen here is we have a brightness value, and every time that the loop is running and running and running, it's going to go up and up and up until we reach 255. And yeah, all that I want to do is change the analog right on our pin number 13 to be brightness. And every time that we run the loop, I want to add a little delay. In this case, it's 30 milliseconds, but that value is completely random. Let's see what happens if we run it. Well, you cannot see it really well here. And maybe let's do the delay to be greater. It should go basically from 0 to 255, and you see it like it's off, and then, oh, okay. I think it's working, but once you do this, you want it to go back down. So what you would do in that case is, oh, it's not what I wanted to do. I guess I don't know how to copy links today. Sorry, copy and paste. But once this is over, this for loop is over, you're gonna be at the value 255. After that happens, you're gonna start at the value 255, and you're gonna wanna be greater or equal than 0, and then this is less or equal to 5 right here. I hope that makes sense. But basically what we're doing is going from 0 to 255, and then from 255 to 0. And we're using the analog write function for that. Yeah, by doing that, let's see what happens now. It's fading. It's really slow. But yeah, again, we have such a, we have such a high resistance value that the effect is not really being shown that well. I guess if we go slower with the resistor, you're able to see it more. But yeah, I don't want to stay here too long. That's basically how PWM signals work. Since you guys don't have many questions, I'm gonna let's keep going to another project, right? Yeah, I mentioned to you guys that the Arduino has analog pins. The analog pins, you can only read actual analog values from them. And as we know, what is an analog value? Well, here, let me see here. What is an actual like analog signal? Well, here we can see instead of being just zeros or ones, it's like a wave. However, again, the Arduino cannot really understand that. So what it does is it converts that analog wave into a set of digital values. And in this case, the range for reading analog to digital in the Arduino goes from 0 to 1023. And that is because the Arduino has an inbuilt 10-bit analog to digital converter. So yeah, whenever we're reading, what this means is whenever we're reading any analog signal, for example, we're gonna see it with the potentiometer, it's gonna go from 0 to 123. And it can be a little confusing because why do you read from that range of numbers? But then when you're creating a PWM one, it goes from 0 to 255. Well, that's because the Arduino has, the ADC is 10 bits, but the PWM circuit is 8 bits. That's the only reason. If you're using another microcontroller, that may be different, right? So this is why this is not like, this doesn't apply to every microcontroller. It's just for the Arduino. So yeah, before I get too deep into that, let's just do a little sketch, right? This one uses a potentiometer, and what we're gonna do is read the analog signal from the potentiometer with analog read. Then we're gonna use the serial command interface to print the values that we're reading from the potentiometer, right? So yeah, that was a lot. I'm so sorry if I went too fast. We're just gonna come here and get rid of our LED. I know this is so sad, but you just delete it. And then we're gonna add a potentiometer. So there it is, but you can search for it, potentiometer. So if you see here, and let me see if I can get closer. The potentiometer has 3 legs in it. 2 of them are for voltage and ground, and they are actually interchangeable. They're actually interchangeable. And then the middle leg actually gives you an output. And that output is an analog signal by itself because it can go from 0 to 5 volts and it can range in between. So yeah, let's just connect, right? One of our legs should go to 5 volts. The other leg should go to ground, and then the middle one goes to any of the analog pins. In this case, I want it to be the 0. Just 1 second. Okay. I'm gonna change the colors because I do like having things color coded. Red. Okay. Now the code. How do we handle a potentiometer? How do we handle analog signals? Well, I already told you guys that when you're using analog, you don't need to tell when you're using analog, you can only read the signal. So funny enough, whenever you use an analog pin, you don't really need to tell the program that you're gonna use it as an input or an output. You can just avoid that step. However, we do want to use the serial communication. So serial begin 9600. If you are asking why we need to do this, well, the Arduino, the way that you print like output with the Arduino is usually done with your computer, and you connect the computer through the cable, and then you're gonna have a serial monitor like this one. That communication is done through serial communication, and you do need to tell the Arduino which baud rate you're gonna be using, and then in your actual monitor, you're gonna also tell the same number, 9600. but you don't really need to worry about this right now. It's just a common number that is used, and it's gonna work fine for printing text. So serial begin, and now we're gonna get rid of our for loops. Instead, let's introduce a variable, and sensor value. This is gonna be using the analog read function. The analog read function, right? What do we do after this? Well, I just want to print this to my console. So serial.print, and I just do sensor value. The formatting for printing here is kind of like Java. If you have any Java class, the format is pretty similar. However, if you want to print things together, you cannot really do that thing where you have basically like print F. You do not have that. So that's something that you need to take into account. But for the rest, it should work fine. Actually, something that you do have is println. So this doesn't happen. Yeah. So right now, by running this, and you guys can tell me if I'm going too fast, but by doing this, you're able to see what happens when you change the knob, when you move the knob in a potentiometer. Why is a potentiometer useful? Well, if you've ever used any radio or anything that has like a volume knob, it's always a potentiometer. And for robotics, it's not very useful, for example, but you can always have, for example, and we're gonna do it, we're gonna have a servo motor moving at the same time that we move this, right? So we're controlling that. But yeah, potentiometer in this case is good as a way to start like knowing what an analog signal is and how to read them with Arduino. So if there's no questions for this, I'm gonna keep going. But yeah, I would actually leave this right here because we're gonna do our servo motor sketch, controlling it with the potentiometer. So yeah, let's go. Yeah, this is what I already told you guys about. This is the source code. We already programmed it. The servo sketch. For the servo, For the servo, we basically have the servo motor, and we're gonna be controlling it with the potentiometer. Now, probably you guys have never heard of a servo before. What is a servo? Basically, if you see this diagram, this is what's inside, like the casing of a servo. It's a DC motor, it's a DC motor with a gearbox and a potentiometer stuck to it. So what this allows us to do is to have like a small motor that can have a lot of torque thanks to the gears. But the potentiometer in here also allows you to decide its movement from 0 to 180. Maybe that doesn't make a lot of sense right now, but if you have a servo motor, for example, it's used a lot for RC planes where you have the flaps going up and down. You will use a servo motor for that. Or if you have any project with a camera and the camera needs to move, around, you could use a servo motor for that. It's really easy to program with the library, and it gives you a lot of control with the angles. So yeah, the idea for this sketch is to move our servo using a potentiometer, using the Arduino library. Yeah, these are some terms that we're gonna use with the servo motor, with the servo library. So yeah, how does the circuit look for that? Well, let's go here, right? And when you use a servo, you see it has 3 legs. And usually the colors already tell you what it is. The orange is for data, red is for power, brown is for ground, and yeah, signal, power, and ground. If you press the R key, you can rotate it. So you would connect again. You can make a whole robot. You can, because you do have DC motors. Like, and this is something that we're gonna do in the next workshop. You have motors and you have motors with encoders, which is pretty cool to have in Tinkercad. And you also have a motor driver chip, which we're also gonna do in the next workshop. So again, shameless plug. If you're interested in that, join our program. um, yeah, that was very shameless. But let's just forget it happened, okay? You connect the power to any pin that you want. In this case, I like the pin number 3. And I'm just gonna try and make it tidy because I do get OCD sometimes. So the ground pin. Also, other thing that you can do is if you click in the middle of the cable, you create another point, and that's really useful. I hope if it looks too complicated, okay. Do you guys want to try using a breadboard, since this kind of looks a little clouded? I do know that we're gonna use a breadboard in the next sketch anyways. But yeah, if you guys want to, okay, if it's still good, okay, yeah. I do want to introduce you guys to a breadboard, but we're gonna do it in the next one. So that is for ground, and then finally have baguette. Okay, they do not have baguettes in Tinkercad, sadly. I already checked, but maybe they should add them. Maybe they should. uh, oh my god. Red, black or brown, I guess. And orange. There it is. So what does the code look like for this? Well, we need to remember that our servo motor is connected to pin number 3. So now I'm gonna, again, like we always do, I'm gonna delete this. And actually we're gonna include a library. And if you check on this like library icon, you can see all the libraries that you have for Tinkercad. There's actually way more libraries than this for actual Arduino, but these are the ones that you're given. One of them is called servo, so we can click include. All that does is just adding this tag. You can include it without doing that step. You just do servo.h. In the next workshop, I'm actually gonna grab like a real Arduino, and I'm gonna show you guys how you do this step with a real one, because it's not hard, but it's something that is good to like be able to relate what happens here with the real one. If any of you guys have any access to a real Arduino or anything, you can also try these projects there. But yeah, before I go out of my train of thought, to use the servo library, you need to create a servo variable of type servo. Yep. Then, well, following the previous, well, let's not do that yet. But in the setup for the servo, you do need to attach, and then you put the pin. And that would be it. Finally, if you want to move the servo, my servo dot right, I think. Yep. And then you would put a value from 0 to 180. Let's try 90 and let's see what happens. Let's see. Oh, no, please. No. Okay. I set it to 90 and our servo motor moves basically to 90 degrees. It's relative to its limits, right? But in this case, that would be 90. Well, that's kind of boring, right? I want to be able for my servo to move dynamically. So what if I wanted to what if I want to control it with my potentiometer? Well, all that I would do in this case is just the same as we did before. We're gonna create a variable analog signal and pin A0. Then we're gonna be able to just use this here. And I'm gonna wait a delay of 20 seconds, sorry, 20 microseconds in between, because the code gets really laggy if I don't do that here. So if I move this, the servo should move with my thing. But I don't know if you guys are noticing, it's not really doing that, right? Why is that? Well, this goes back to what I told you guys about the analog read and the PWM having different ranges. So the pin number 0 is reading a range from 0 to 123, but the servo motor library can only output from 0 to 180 because that's the range of angles, right? So you would actually need to map our analog signal value from, and there's actually a function in Arduino for that. You stop the simulation and you can create a map from 0 to 123 to 0 to 180. Let's see what happens when we do that. It doesn't like it. Okay, let's see why though. 0 to 123, 0 to 180, too few arguments. Oh, okay, my bad. You do need to input analog signal first. So now when we rotate our potentiometer, it does the same, but it's kind of rotating backwards. So something that you can do as a quick fix is just change the limits to be reversed. By doing that, it's gonna kind of follow the potentiometer like that. And again, that's just one cool little sketch that you can create. And if you guys have any questions, let me know. But if not, let's just keep going to the last part, which is gonna be the IR sensor with the controller and all the lights. That sketch, I haven't really been able to test it too much, but I'm excited to do it right here with you guys. So yeah, let's actually get rid of this whole thing. You can press Shift, or is it Control? Oh no, you first need to stop the simulation, then Shift, and you can select everything, and then delete it. Okay, so, yeah. For the IR receiver sketch, since the sketch is really big, I wasn't really able to fit it in here, but I think it's okay if we do it together. For this sketch, we're gonna use the IR remote library. So there's a few elements that we're gonna need for this. The first one, of course, is an Arduino. You put it in the area here. Then we're gonna need an IR receiver or IR, well, IR sensor, they call it, and a remote. You could actually, if you have an Arduino and an IR remote, sorry, an Arduino and an IR sensor, you can grab any control that you have in your house for, no worries, by the night. You can grab any control that you have in your house for like TV and everything. And you can read the codes that it sends. Because the way that IR communication works is basically the control has an IR transmitter and it's sending IR signals kind of similarly to the way that PWM works. And I'm gonna show you here. They kind of look like that, right? But they're sent through infrared. And basically every key that you press in the control is gonna send a different signal. And you can program it. You can program the Arduino to read those signals and do stuff when that happens. So what I'm gonna do today is just control 4 LEDs, but yeah, you can imagine whatever you want. Maybe you have in your room and you like the Arduino Workshop and you decided to decorate your room with an LED strip using an Arduino, right? No worries, Bill. See ya. Maybe you decided to decorate your room with an LED strip and you programmed all these cool animations and you want to be able to control them. Well, you could use an IR control like this. Finally, I'm gonna add a breadboard for now. And we still do not have any bread, but we're gonna make it through, guys. So the way, if you've never used a breadboard before, the way it works, and Tinkercad is great to show you. You have the power lines, positive, negative, and they're all interconnected. If you connect something here, it's gonna be the same as connecting it here. However, the ones in the middle, they're connected this way. So yeah, if you wanted, for example, I could plug my IR sensor here, and one of the pins is ground. So I'm gonna start like here and put a cable, and this is gonna go to ground. Wait. Then I want this one, this is out. So this one actually goes to one of the digital pins. And it has to be a PWM one. So, oh, that's something that I forgot to mention, you guys. Just let me go back. We talked about PWM signals and how they're cool for creating, like simulating analog signals, right? Well, the Arduino has PWM signals, but not for every pin. Actually, just pin number 3, 5, 6, 9, 10, 11 have PWM. And the way you know that is because they have a little, I don't know the name, but that symbol in there. BIMO. Yep. So that's ground, then power, that's connected. In here. And finally, the signal. I'm gonna do pin number, let me do pin number 11. It doesn't really matter which one you choose. It's just, honestly, whatever whatever one you feel like it. But you do need to take that into account in the code later. So we just did something simple here. We connected an IR module and we have a controller. We're able to, whenever we start the simulation, we're able to press the buttons and they are gonna do something. How do we know the codes that the control is sending? Well, first let's get rid of our setup code here because we don't want it yet. There's a couple of things that we need to do here. Serial monitor, yep, that's one of them. So serial.begin, oh my God, 9600. That was a good observation. We need serial monitor. We're also using one pin from the IR sensor, pin number 11. So you can either write it here, pin mode. One second. Okay. Yeah, I'm sorry for that. I'm just following through with you guys here. But let's skip that pin for now. Instead let's just create a simple code here that is like serial.print. We're gonna enable the IR, enabling the IR sensor, right? Then if we use the IR library here, it's include IR remote. And actually, let me do it from here. Since, yeah, before using a library, you can check here if it actually included, right? So it's the IR remote library. What you do after that is, oh, I get it now. Yeah, you don't need to set the pin to 11 with pin mode because the library already does that to you when you instantiate, when you do this code right here, IR res. And again, whenever you're using a library, you would just like find an example code online, or you would read, the documents for the library, and then you can know exactly like what to do and stuff. So yeah, these are two, basically, I guess it would be objects that you need to create. One of them is, well, actually it's just a variable, and this is just calling. This is just calling that and giving it the pin. In our case, you could either create a variable up here, like a constant int, and be 11, and that constant int will be called receive the pin. Or you could just put 11 straight up. It's the same. Yeah, so we're enabling the sensor. Then we need to call this right here. And then finally, we can say that it was enabled. Serial print IR sensor enabled. Let's just run the code and see if it works, because maybe there's something not working. Yeah, it's not declaring the scope. So just give me 1 second so I can check this. That's good. Decode results, line 11. Yeah. IR receiver enable N. Doesn't make a lot of sense. Yeah, just give me 1 second, and I'm so sorry for this, guys. I just got like time to test it once before and it worked, but now it's like being a little icky. Okay, I found it. I found it, guys. You were right. You were right. It was 9/11, and it's still, well, we're closer. That's what matters. Enable IRN. Okay, missing character, terminating character. Here it is. Okay. Well, I think it's running. Yeah. Now you would do println. And at the end of this, I'm gonna paste the code, because if you guys wanna, yeah, if you guys wanna, like, since all this terminology is from the library, it doesn't really, like, if it's okay if you guys also like have an error or something, I'm just gonna paste the code once we're done so you can test it yourself and play around with the sketch, which is definitely a fun one. So something that we do with this library is actually you can check in the loop if you received a code. You do this by using IR like this, and then decode, and then you grab the pointer from, you grab the value from results, pretty much. And this should only be true when you read a value with the sensor. So what you do now is you create an integer called value and results. You grab the value result from here, and then you can print it. System.out println, and that will be value. This is not Java. Oh my God, this is not Java. That was embarrassing. It's actually serial. Oh my God, value. Yeah, that was, yeah. So if I press 1, oh, we're getting, okay. So something's happening. We're getting repeated. We're getting that value repeated. So I think actually we need to create this to be unsigned. Let's see now. Okay. Well, we're getting there. So far what we've done is we included the library, we created the IR receiver with the pin results, pin mode, serial begin, we started the library. Now if, okay, let's try this. IR receiver resume. Okay, that was it. There we go. Oh my God, I am so sorry, guys, but we're done. We're there now. So if you guys notice, when you press every one of the buttons, you get a new code, right? You could actually grab an IR sensor like this and grab your control from your TV, and you would get the values from that. Then you can create logic with it, right? So that's where the I'm just gonna go through it again. We included the library. You need to tell the library which pin you're using. Then you need to create basically a variable here that's gonna grab the results. This is using the library though. So then we set up the serial.begin to be able to communicate with serial monitor. Then we started the IR library basically. And then here we use this parameter. It's only gonna be activated when you read a value. There's an actual value in the results. Then we get that value. We get that value and we put it to the variable value, and then we printed it. This is as far as we got, right? And you do need to put this command here to go to the next one. So that's what we were missing here. IR receiver resume. If you don't do this, it's gonna keep trying to read the previous value. So let's do something now. Let me create, I don't know if you guys have used this, a switch statement. Basically, it's gonna allow you to switch between, you know, a bunch of different cases. We already saw that one, in this case, one is 22695. So when I have a case that is 22695, no, never mind, that's not it. Let me check it again, just in case. If we press 1, what does happen if we press 1? It's 2295. So let's create a case called 2295. And this right here, scroll erases. Okay. So in this case, we're gonna turn on one of our LEDs that we haven't set yet. That LED is gonna be in pin number 3. And I'm gonna set it, well, let me actually do pin number 7. And I'm gonna set it to high. And then a delay of, I don't know, 1 second, and then set it to low. Well, let's do half a second. Digital, right. 7 to low. And then we can break from this case. Now we're gonna copy this and we're gonna repeat that for 4 LEDs that we're gonna create. So another case and another case. It looks kind of bad right now, but we're gonna make it, we're gonna try and make it look better. Yeah. And the last case. So I already wrote down what the cases are. So the number 2 is gonna be 3, 4, 9, 3, 5. Then 1, 8, 6, 1, 5. And then finally 1, 0, 4, 5, 5. This is gonna be pin 7, 6, 5, and 4. 7, 6, 5, and 4. So you guys can see that what's happening here is we're basically constantly reading the values from the IR control. Then if any of those values happens, something is gonna switch. One of our LEDs is gonna turn on and then off. So let's actually grab another breadboard and set up the LEDs here. So, yep. I'm gonna grab 3 LEDs. And they're gonna be different colors. So 1, 2, 3, and 4. You can change the color of the LED by selecting it. That yellow is kind of ugly. Why? Well, I guess they look better when you turn them on. Orange, no, green. Okay. We already know that the cathode is gonna be to ground. So let's do something here and let's connect all the grounds to the negative rail in the breadboard. And then we can connect this ground to here. So that is all black like that. Do you guys understand why I'm able to do that? Because by connecting this rail here to ground, basically everything is connected to the same ground. Yep. I'm not gonna do the same with the 5. You will usually also put like 5 volts into this line like that, but we're not gonna use it in this case because the voltage the LEDs are getting it from the pins. So this LED is gonna go to 7, this one is gonna go to 6, this one to 5, this one to 4. Yeah. This one's gonna be red, blue, yellow, and green. Okay. So we need to take those lights into account, right? Those LEDs. I'm actually gonna pin mode 5 output, pin mode 6 output, and same with 7. Sorry, actually it was 7, 6, 5, 4. So those are all outputs, and we already set up the logic for them. So let's see what happens if we try to run this. Well, I did forget to put the semicolon after the breaks. So yeah. Okay, I think it's happy now. So if I press 1, let's see what happens. Does it read it? I love seeing those errors, brings me back. I know. So I actually, little mistake. The value is 2295 and I wrote 2296. You see? And if you put a different controller, the values are going to be different too. That's why whenever you buy like a universal IR controller for your TV, you need to program it to the exact TV that you have because every controller is different. But I don't know if you guys saw that. Oh, man, I forgot to put resistors. So it's funny because Tinkercad will tell you if you messed up like that, because like if I press it, it gives me like a warning sign. But if I press it 2, 3, and 4, you see how the LEDs turn on? In real life, you will be able to do not only this, which is simple, but like any kind of action. Or if you were like Raul wanted to do laser tag, you could do it this way. You just need to see what the code is from the laser gun. Then you could do whatever you wanted. But I think if you guys have any questions, let me know. If you want the code, I'm gonna paste it here. I hope I copy it right, finally, or not. Oh, that's a big one. Yeah. But yeah, if there's no other questions, I will say once more, if you're interested in the part 2 of the Arduino workshop, I'm gonna send the link again, but it's basically UPE. Sorry, I have it here. Yeah, this is the link. And yeah, you can join the program. But if there's no other questions, thank you so much, guys, for attending. And I hope you were able to learn something new, definitely. And thank you, guys.